Today we're going to start looking at transformations of our quadratic functions. So we're going to take quadratic functions y equals ax squared, and we're going to see what changing the a value does to our parabola. So what we're going to do is we're going to start out with just graphing and looking at the parent function. So the parent function of all of our quadratics is this y equals x squared. So in order to see how y equals x squared graphs, we need to make a little table, x and a y, so that I can get some points to graph. So we'll put our x over here and our y. So if x is 0, y is 0. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. If x is 3, 3 squared is 9. So now I have some points that I can graph. Let's go ahead and do some negatives. So negative 1 is 1. Negative 2 is 4. And negative 3 is 9. I went ahead and did the negatives so that you can see negative times negative is still positive, and that's what gives us the U-shaped graph. So let's go ahead and graph these points. So we've got 0, 0. We've got both 1, 1 and negative 1, 1. We've got 2, 4 and negative 2, 4. And then let's count on up. We have 3, 9. It'll be up here. And then we've got negative 3, 9. So now I can go ahead and draw my parent function. Okay, so now that we've drawn the parent function, I want you to pause your video and fill out all the basic information about the parabola like we were doing in the last video. And once you've got it all identified, start the video back up. Okay, so our a value in the parent function is 1. Our coefficient to the x squared is 1. And this is what our parent function looks like. It's our very most basic quadratic function. Now we're going to start looking at what happens when we make changes to our a value. So let's look at number 1. In number 1, I got g of x equals 2x squared. My a value is a 2. And from just looking, we've got to make a quick little table so that we can graph our function 2x squared. So go ahead and pause your computer so that you can fill out some points on the table, and then go ahead and graph the equation. Once you have everything graphed, then go ahead and start the video back up. So when I plotted my new parabola, the 2x squared, notice that my blue line is narrower than my parent function which was already given on the graph. So we call this a vertical stretch. The parabola's gotten narrower. It's called a vertical stretch. So imagine a can of Play-Doh and the little regular form in that cylinder. If I grab both ends and started stretching, it's going to get narrower. So that's the visual way to remember what vertical stretch looks like. Okay, on number 2, I want you to go ahead and pause your video and create a table and graph number 2, and then turn the video back on. Okay, so when I filled out a table and graphed it, notice that I still have the same vertex as my parent function 0, 0, but now my graph is a lot wider. We call this a vertical compression or a shrink. So if you think about that same can of Play-Doh, if I compressed it or pressed it down, it would splat out the sides and it would be wider. So that's another way to remember what a compression looks like. All right, so now let's move on. down and kind of just analyze what we have figured out. So when we're only changing our a value, look at these two examples. When I changed the a value, that's all I changed. Did my vertex change? The answer to that is no. No, vertex did not change if all I'm changing is the a value. Now, we did an experiment with what happens with a negative a, but both of the examples that we used, our a values were positive. One was greater than 1 and one was smaller than 1. So if you know that a positive number had the parabola open up, what do you think would happen if our a was a negative number? Well, it would open down. So that's one of the things that we look for. Once you've used that negative sign to open up or down, then we don't think about the negative anymore. So then we just look at the a value without the sign, and we decide if it's a vertical stretch, which is narrower, or a vertical compression that's wider. So if our a value, not taking into account the negative sign, if it's greater than 1, then we're going to have a vertical stretch. And a vertical stretch is the same as thinking about it as narrower. And vertical stretch is the way that we use the words most often in higher math levels and in the rest of Algebra 1. Now, if it's between 0 and 1, a fraction less than 1, then we're going to have what we call a vertical compression. And a vertical compression is also thought of as wider. So what I want you to do then is now look at our two examples that we just did, number 1 and number 2, and describe what the transformations are. So in number 1, we had a vertical stretch, and what we would say is it's a vertical stretch of function f, which is our parent function, by a factor of 2, because the 2 is what we were stretching it. And then for number 2, we have m. M is a vertical shrink of our parent function by a factor of 1/5. In other words, m is wider than f. Okay, just check and make sure that you got all of that written down.